Hello everyone. So today we've joined for two very talented young students. So they will be presenting their work on applying AI to that intricate domain of VVIP driven asset pricing. So let's hear from them now.
So, hello everyone, my name is Sritha, and this is the project on AI for VVIP driven asset pricing. Our project aims to develop a model that predicts the Tesla stock price based on Elon Musk tweets. We've divided this project into sections, namely introduction and background, sentiment analysis techniques, data collection challenges and solutions, models in experimental environment, and findings and potential environments improvements. Next slide, please. Yeah. So, this is the introduction. We all know that social media can reshape one's opinions on themselves as well as market reactions. Especially influencers like Musk and Warren Buffett can move stock prices on platforms like Twitter or X. We aim to build a model that predicts the Tesla stock price based on one specific person's tweets, Elon Musk. Traditional models they tend to miss emotional data and tweets tend to reflect investor sentiment. We found a strong correlation between Musk tweets and the Tesla stock. We analyzed the tweet emotions via AI, NLP, etc., and matched the tweet tone with price changes. We found that influence and sentiment are the key factors for our success. Next slide, please. Right. So, this is the related works. So, there is a paper published on the Stanford website by Mr. Christian Palomo. So, he used a financial bird sentiment analyzer along with a random forest classifier. He used mixed public sentiment and not specific sentiments. There is another work by Mr. Kumar who used the Vader / TextBlob sentiment analyzers along with an LSTM classifier. However, our focus is on must tweets only, and we've used the Twitter Roberta sentiment analyzer, which is trained on tweets. It is also better for slang, irony, and emojis, and we isolated only the influencer's effect. We found that person specific impacts can give a clearer signal. Next slide, please. So, this is about sentiment analysis. So, we've used the NLP method to extract emotions from text, and this method is commonly used in media, finance, and marketing, and all other AI fields too. We evaluated 3 model types for tweets and 3 sentiment analysis too. We found that they must handle sarcasm, slang, and tone. We also compared the lexicon and the transformer's performance, but found that it needed a strong context understanding, which is why we chose Roberta, because it's pre-trained on tweets and understands that tweets are complex, short, and informal. We have found a correlation between sentiment and Tesla reactions. Next slide, please.
So we are using Olama are running on Google Colab for this project. We are running Llama 3.3 as our core model. So we are utilizing the 128,000 token context token memories for uh, training the model so that it remembers what we give it. It supports full tweet history input. It works well with real-time predictions, and it has higher accuracy without needing retraining. This use of LLM also increases the context awareness, and we've built the front end, which you'll see later, with the Python Flask. This solution overcomes short context limits, and we have used the Llama 3.3 model. Next slide, please. So about zero shot classifiers, there is no training needed for the task, and then it just classifies the tweet in binary, either up or down. This is based on the language understanding that the LLM has. This is quick, scalable, and a pretty good sentiment tool. This matches the tweets with the price patterns and adapts to real-time data easily. This is because of the use of an LLM rather than building a model from scratch. Next slide, please. So when we compare this with our remake of the random forest classifier, we found that our model using Llama 3.3 as our core LLM performs better. So we had used Twitter Roberta as our sentiment analyzer, and initially we were affected by memory leaks. We were able to rectify it later, but then all of the issues and the lack of accuracy forced us to switch to the Llama 3.3 LLM. We have used a wide context inferencing method. We don't really need retraining, we just need longer context prompts. This has helped us achieve a better accuracy overall with our LLM. And one thing we've noticed is that zero shot classifier plus inference is a pretty good combination.
Yeah. So, data collection and sentiment analysis. We first tried scrapers like Acid Scraper and TweetP to get the required data, but this eventually failed. And Twitter API, which we originally wanted to use, became paywalled. So we started using Knitter as a proxy for scraping. We used multiple URLs, but originally came back to the knitter.privacydev.net. After getting only about 20 tweets from this site, we moved to a Kaggle dataset by Neil Gajare that had all of Elon's tweets from 2022. We've cleaned about 2,000 Musk tweets, 2,000 to 3,000 Musk tweets for use. And as part of pre-processing, we removed retweets, links, formatting, and etc. After training this with our Llama 3.3 LLM, as mentioned, we found strong tone price correlations, and also that Roberta gave the most reliable sentiment compared to Lexicon and Transformers. Next slide, please.
So we'd used, as we had mentioned, we have used Olama, a context window approach. All we had to do was just automate the refeeding of the tweet data at each session when we use the model. Because when you end the runtime on Google Colab, all of the data gets deleted. So all you have to do is just refeed the model, and we have automated that too. This has also helped us avoid the memory leak before, and then this enables long range trend modeling. As I have mentioned, we are using Llama 3.3 as our core model. This goes to show simplified flow versus traditional training. For us, our simplified flow has done a little better, and then we do recommend that you batch input the data into the model for more efficiency. We realized that this LLM helped us get a wider pattern recognition because it doesn't need to think only based on sentiment scores. And yeah. Next slide, please. So we had performed multiple experiments. Our first one was to use Google Colab and the free GPU tools. This was not enough because Llama 3.3 requires about 40 gigabytes of virtual memory, and that was not being satisfied with the free tier, so we had to eventually upgrade. We did try using VS Code and running it locally, which didn't work very well because our computers weren't powerful enough to run Llama 3.3, so we had to scale it down to a smaller model, which gave us a lesser accuracy. So we switched back to Google Colab as our Olama host. And then we had compared multiple sentiment analyzers, as Sritha had mentioned, Vader, TextBlog, Roberta, Finbert, and all of those. We have realized that Roberta was our top performer, so we proceeded to use it. Eventually, it came to the point where we didn't really have the necessity for a sentiment analyzer, but this is what we have done. And then we realized that the charted tweet sentiment versus the price has strong correlations, especially when you look at it from using the LLM. And then we found that spikes are tied to events better tweets. Sarcasm was captured better by LLMs more than Twitter Roberta or any other sentiment analyzer or even our model from scratch. We have realized that this setup proved to be useful for real prediction. Next slide, please.
Right, so this is a few results. So we have made an application using Llama 3.3 with an accuracy of about 88.33% and a fairly good looking UI. On our attempt on the recreation of the random forest classifier with the Twitter Roberta pipeline, we found it to be highly inaccurate, which we deduced from the countless experiments that we did. Next slide, please. Right, so these are our results. This is the table with the models along with scores accuracy scores and F1 scores. So, our model with the sentiment analysis gave us an accuracy score of about 0.86 or 86% and an F1 score about 0.81. Our model without the sentiment analysis, however, gave us an accuracy score of about 88.33%, which is quite interesting, and an F1 score of again 0.81. The random forest classifier recreation with the Roberta pipeline gave us an accuracy of about 0.57 or 57% and an F1 score of about 0.53. Next slide, please. So, this
This
is
is
a
our
graph.
data visualization of our model accuracy. As you can see, our model without the sentiment analysis has performed the best, and this is because of multiple reasons. Next slide, please. This is a confusion matrix based on 3,000 data points for our Llama 3.3 model. This is how we had deduced our accuracy score of 88.33%, which is pretty good. Next slide. This is a video to show our UI and how we use it.
Okay, so first we're gonna run our Google Colab code. I've already run it, as you can see. It does take a lot of time to run. So we are now going to copy the Llama host URL, and now we're going to paste it in our terminal. As you can see, I've already done that. Next, what we're going to want to do is our Llama run Llama 3.3. It has finished installing. Now we're going to run our Python Flask application. Okay, now it's running. We're going to open it up in our web browser. We are going to type a tweet in which says that Elon Musk leaves Doge to focus on Tesla. Historically, it's shown that the market is going to go, the Tesla stock price is going to go up. It has predicted up. Now we're going to go to Twitter, and then we're going to copy a retweet of Elon Musk. Historically, this tweet has made the Tesla stock price go up. Now we're going to paste that into our model, and it's predicted that it is going up.
Right, so we have concluded that tweet sentiment does affect this Tesla stock, and influencer identity is also a crucial factor. Let's say we had chosen another influencer like perhaps Warren Buffett, then we might have gotten different results. And we also found that there was only about a 33% match between the TextBlob sentiment analyzer and the Twitter Roberta, which goes to show how accurate the Roberta sentiment analyzer is. In future work, we want to add features like timing and trading volume and fine-tune Llama 3.3. We also want to try an LSTM plus transformer mix, or rather LLM mix, and improve the UI, which we were unable to show. However, we want to add more charts, alerts, and backtesting too. We also want to combine sentiment, context, and identity. Next slide, please. So, these are the references that we took throughout our work. The first one is by Mr. Singamaneni, Kranti Kumar, and others. You can see the DOI and the year it was published. This is the one with the LSTM classifier. And then there's another paper by Mr. Christian Palomo, which was in the Stanford website, and it was also published in 2022. Thank you.
Thank you, guys. It was a nice presentation. I actually did see the video, so it was very nice. So, in closing, we extend our sincere thanks to these young presenters for their very insightful contribution to the evolving field. So, we are definitely looking forward to see where this research leads us to. Okay, so for any questions, please leave us in the comments. Thank you, guys.
Yeah, thank you so much, guys.
Thank you, ma'am. Thank you, sir.